So in this session, to get a better output, we have to perform some transformations on the image that we are using. And the first transformation that we are going to apply is converting the image into grayscale. So for that, let's run this cell and perform the operation. So here you can see that our image has been converted into grayscale. The next thing what we will do is we will apply Gaussian blur. It removes the noise from the image. So instead of a box filter consisting of equal number of filter coefficients, a Gaussian kernel is used and it is performed using the function of Gaussian blur CV2. So we just need to specify the height of the kernel, which should be positive and an odd value. So let's run this cell. So you can see the image. Next we will see how to dilate an image. So here we will dilate the image using dilate function. It is just the opposite of erosion function. So let's run this cell and dilate our image. So here our image is being dilated. All these operations or all these transformations are necessary because in order to get the correct output. So now the next step will be performing the morphological transformations with the kernels. So we are using morphology EX, which is used to find the difference between the dilation and the erosion of an image. We may need an elliptical or circular shaped kernel. So for this purpose we are using the OpenCV function, get structuring element, and we just need to pass the shape and the size of the kernel and we get the desired kernel. So let's run this cell and perform the operation. Here you can see that the morphology has been applied to an image. So let's move forward. So next what we'll do is we will need a cascade to detect the cars. And as I have already showed you the cars.xml file, I have downloaded it from the internet. So this is that cars.xml. This is the hard cascade file for car detection and I have stored it in the file section here. So we know that car.xml file, and what we'll do is we'll create a car cascade using Cascade Classifier. So first we need to upload them to the Colab and then specify the paths of the car cascade SRC. Now OpenCV provides a training method which is the Cascade Classifier training or the pre-trained models, and that can be read using Cascade Classifier method. As you can see here, car cascade SRC file. We need to detect multiple objects, that is cars. So we will be using detect multi-scale function of car cascade. It detects objects of different sizes in the input image and detect the objects and return them in the list of rectangles. So let's run this cell and perform this operation. Next, what we'll do is we will use the above written contours and draw a rectangle around all the detected cars. So here we will see that it will create the rectangle with the red boundary color. So this represents the red color RGB values around each and every car that it detects. So let's run this cell and see the output. So here there are 21 cars found in the image which we have given as input. So which are bounded with red color rectangles, and few cars which are not detected because they are not 100% accurate, but most of the cars are detected using this. Now let's move forward. Now we will use another image, that is bus image. You can take any bus image and we will fetch that image from the internet here. Here you can see that I have taken the URL from the internet and the request will fetch this image and we can store it using image.open in a image2 variable. Similarly, we will resize this image also. So here you can see that I have sized it into 450, 250 or 450 by 250, and also I am converting as a NumPy array which will be further converted into grayscale image all in one step. So let's run this cell. The next step would be, as we are working with bus image here, so we require the cascade for detecting the bus, and I have already told you that I have downloaded or uploaded my busfriend.xml file here. So I am passing busfriend.xml, and similarly as we have the cascade classifier above, we'll use the same cascade classifier and call the bus cascade src function here. And as we are detecting the multi-scale, we are detecting multiple buses. So we are using this detect multi-scale function also. So let us run this cell and perform the operation as performed above. After this, as we did in the car cascading, in the same way we will be performing the same contour operation on the bus images also. And here we will create a rectangle around the bus if detected any with red color boxes. So let's run this cell. So here one bus is identified and it is shown with the red box. So next we will do is we will perform the vehicle detection and counting in a video. So video runs by frame to frame. So for creating the output video from frame or images, we need to use cv2.videowriter. So what it does is it takes a path with extension as a first parameter. Second parameter is the code for the output. And then we also need to pass the frames per second and height and width also. So here you can see that I have passed results.avi as my output file. It will use the video writer. divx will be the code for that. And this is the height and the width of the frame or the video. And this will be the height and width of the video. So in file section, we have already uploaded the mp4 file, that is cars.mp4. So let's run this cell and check it out. So after this, what we will do is we will read the video frame by frame, the input video, and we'll convert that into grayscale using hard cascade. And we will detect the cars in that particular frame. And in the end, what we'll do is we will write the whole video using the video.write method, and then we will save. And in the end, what we'll do is we'll write the whole video using video.write method, and then we will save it using video.release to a given path. So let's run this cell and convert our image and video into grayscale, and using the hard cascade to detect the cars in that particular frame and save that video frame by frame by frame using video.write and video.release function. While selecting a video, you should take in consideration that it should contain some images, some cars in it, or any object that you are working on to detect that object. So let's run this cell. It will take some time. It depends upon the video how big or large video we are using. So while selecting a video, you should take in consideration that it should contain some images, some cars in it, or any object that you are working on it to identify or to detect that object. So here I think it will be taking some time for that. So here, as you can see here, we have used a cv2.rectangle for detecting the cars and to detect the multi-scale as well. And we have used colored images and we have converted them into grayscale. And in the end, we have saved the video. So with this, we have come to the end of this project. So we started with downloading the image that we will be working on and perform some operations on that image. So you can see how much pre-processing we have done on the image that we worked on. Similarly, we saw how we can use hard cascade, which is used for object detection. We used hard cascade for car detection and bus detections. Similarly, there are many pre-trained hard cascades for different object detections. So the scope of this project is that a hard cascade is used for object detection. We have a very vast scope and it can be used for any type of the object detection. And as I have already told you, you can also create your own custom hard cascade for specific objects. So this is all about the project on vehicle detection and counting using OpenCV.